In this video, we're going to go through the practice questions for our counting, combinations, and permutations topic. And question number 1 states coffee sizes come in small and large, can be hot or cold, and are available in 3 different flavors. How many different possible orders of coffee can there be? So we are looking for a number, and we get that from our answer choices here. And when we're looking at the possible orderings of how we can make a coffee order, here we have sizes are the first one. The size can come in large or small. So we have a large or a small. So that's 2 possibilities for that. It can, temperature-wise, we'll put temp, can be hot or cold. So that's 2 different possibilities for that. And then we also have 3 different flavor options. So we'll just label that as 1, 2, and 3. So 3 different flavor options. So let's just think a little bit about an individual coffee order and using these different options, what we can come up with. We could order a large drink that's hot with flavor 1. I could order a large drink that's hot with flavor 2, a large drink that's hot with flavor 3. And that's just 3 of the options we have. When we want to consider, we could have cold with each one of these 1, 2, and 3. And we could have a size small for each one of these. So when we look at each of the different options we have, when we're coming up with different orderings, all we really have to do is we look at the number of different ways that the options there are, and we will multiply these together. So we'll do 2 times 2 times 3, which turns out to be 12. So that is answer choice E. There are 12 different possible orders for coffee. So this is a counting example. And so basically what that says, if there are X ways to do one thing and Y ways to do another, and in our case we have 3 things, so we could say in Z things to do another, we're just going to multiply X times Y times Z to get how many different possible options we can come up with. So we just multiply those together. Now question number 2 says Susan opened a trouble ticket with the computer help desk. The ticket number generated was a 7-digit number using the digits 0 through 9. The digits can repeat. How many possible 7-digit trouble ticket numbers are there? So we are looking for how many 7-digit trouble ticket numbers we can come up with this. So there's some key information in this question. We know it's a 7-digit number. So let's just look at this. 1, 2, 3, 4, 5, 6, 7. We have 7 spots to fill in with digits. And we're using the digits 0 through 9. Remember, when we're talking about 0 through 9, that is actually 10 digits. Sometimes that can trick people. They think we're just talking about 9 digits because we see the through 9. But when we add 0 in, the 0 through 9, that's going to give you 10 digits as your options. Now we're also told that the digits can repeat. So that means if I use a 0, yes, I can use 0 again. I could have all zeros or I could have all ones. So each option of this 7-digit number, we're going to have 10 options for the first one, 10 for the second, 10 for the third, and on and on and on. Each one of them has 10 options. So when we look at how many possible different ones we could have, we're going to have each one of these. It's sort of like the number 1. We do the 10 times 10 times 10, on and on. We have 7 tens. So a shorthand writing of that, we've multiplied 10 together 7 times. That's 10 to the 7th power, which is answer choice J, 10 to the 7th. Question number 3 states that a committee is selected from a group of 10 men and 8 women. The committee will be comprised of 3 men and 3 women. Which of the following expressions gives the number of different committees that could be selected from these 18 people? So when we take a look, when we glance at our answer choices, we see that combinations are indicated in choices A, B, and C with the capital C in that notation, and for permutations in D and E, which is indicated by the P in those notations. So that's what we're having to determine. First of all, are we talking about a combination or a permutation? Well, there's a key bit of information here. Actually, the entire question gives us everything we need. But if we look at this second sentence, it says the committee will be comprised of 3 men and 3 women, and it doesn't tell us any other indication about ordering being important other than that it's men and women. So we have 2 distinguishing groups, but within the picking of that, it doesn't appear that order matters. So when order does not matter, we're talking about combinations. So we know we can eliminate options D and E because those are permutations. Now, because we're talking about 2 distinct groups, we're talking about men and women, we are going to have 2 different values that we're looking for from the values of men that we're picking and then the number that we're picking for women. So that's going to eliminate option C because that's just one ordering. Now we need to see which one are we talking about. Well, if we remember our notation for both combinations and permutations, the distinguishing thing be if we put a C or a P, but with combinations we have our total sample set that we're choosing from, and then the number that we choose, R. You can use any notation just as long as you remember the number to the left, the subscript, is the total number in the sample set, and the one to the right is the number you're choosing. So if we look at men first, we have 10 total men and we're choosing 3. So that's going to give us 10 men and we choose 3. And from this, we're going to multiply that with our women. We have 8 women and we're choosing 3 of those. So that matches up with answer choice A with the combination notation for this committee that's going to be chosen. Taking a look at number 4, the breakfast shop has 5 different kinds of bagels, 6 different kinds of smoothies, and 3 different pieces of fruit to choose from. How many possible orders consisting of a bagel, a smoothie, and a piece of fruit can a person order? So this is very similar to question number 1. We are looking at a breakfast combination with 1 bagel, 1 smoothie, and a piece of fruit. And we know we have 5 different bagels. We have 6 different options for smoothies. And we have 3 different options for our fruit. And remember, with our fundamental counting theorem, we're going to look at X different ways to do one thing, Y different ways for another, Z different for another. We're just going to multiply each one of those together and we get 30 times 3, which is 90. And that is answer choice J. We can come up with 90 different possible orders with these different items to choose from.